In Unit 9, we're looking at probability. So 9.1 just focuses on basic probability. So probability will always be a number between 0 and 1. A probability of 0 can't happen. So like if there's a 0% chance of something happening, then that means whatever that event is will not happen. A probability of 1 will happen. So if you give, so that would be guarantee the event happening. A probability closer to 1 is more likely it will happen, and then closer to 0 is less likely it will happen. Now, probability can be written as a fraction, decimal, or percent. So, some things you're going to be asked to do is say which event is more likely to occur. So remember, the closer to 1, the more likely it is to occur. Now, so how we would read this is the probability of A equals 0.4. The probability of B equals 0.5. So we would say P of A is less than P of B, because that 0.4 is smaller than that 0.5. And number 2, if fractions aren't your thing, make those fractions decimals. So 2/3 is about 0.67 and 3/4 is 0.75. So the probability of A, 0.67, is less than the probability of B, 0.75. Then we have 0.23 and 1/4. I want you to try this one yourself. So 1/4 is 0.25. So the probability of A is less than the probability of B. They won't always be less than, that just happens to be how all of these problems laid out. So if I do another example, if I say the probability of A equals 0.9, or the probability of B equals 0.8, then in this case, the probability of A is greater than the probability of B. So knowing your less than or greater than signs is important for this. Okay, so in marble problems, you'll always add all your colors together to get your denominator. So you'll always have a part over a total. So in this scenario, we have 5 red, 4 blue, 3 green, and 9 yellow. That adds up to a total of 21 marbles. So I want to know the probability of drawing a green marble. Well, if I have 3 green marbles, that's 3 out of 21, which we can reduce to 1/7. If I want to know the probability of a red marble, that's 5 out of 21, which is still 5 out of 21. A blue or green, well, there's 4 blue and 3 green, so that probability is 4 plus 3 out of 21, which is 7 out of 21, which is 1/3. And a yellow or blue. So there's 9 yellows plus 4 blue out of 21 total. 9 plus 4, 13 out of 21. You also might be asked to or if you're randomly picking numbers between 1 and 30, or 1 and another number, inclusively, meaning we're including 1 and 30. So that means our total in this case is 30. So these will all be out of 30. So evens Well, every other number is even. So 2, 4, 6, those are even numbers. So that means if we have 1 through 30, half of those are going to be even. So that probability of drawing an even is 1/2. Perfect squares, well, remember that's numbers that when you multiply themselves, it's that answer that you get. So 1, 4, 9, 16, and 25 are all perfect squares that are from 1 to 30. So that is a total of 5. 5 out of 30 is 1/6. And divisible by 3. Well, if we're starting with 1, every third number will be divisible by 3. So that means a third of those numbers, so 10 out of 3, are going to be divisible by 3. Another way you can do it, make a list again. 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30 are all our numbers divisible by 3. And I count those up and I get 10. 10 out of 30 is 1/3. You also will be asked questions regarding decks of cards. So to familiarize you with decks of cards, if you didn't know this, there's 52 cards in a deck. They go from numbers 2 to 10, jacks, queens, kings, and aces, with there being 4 of each number or face card. 4 suits, hearts, diamonds, those are red, spades and clubs, those are black, and there's 13 of each suit. And then 26 of each color. So, find the probability of the following, the probability of drawing a 4. So our total is 52, and if we draw, there's 4 4s in a deck, so that's 4 out of 52, which can reduce to 1 out of 13. The probability of drawing not an ace. So there's 52 cards total, 4 of them are aces. So that means 48 of them are not aces, which reduces to 12 out of 13. Drawing a red 10. Well, there's 4 10s in a deck, but only 2 of them are red. So 2 out of 52, which reduces to 1 out of 26. So it just comes down to knowing what is in a deck of cards. So if you want to pause and try these ones, you can. Okay. So now another thing that we need to know is theoretical probability versus experimental. So theoretical is what should happen. So for example, if I'm flipping a coin, ideally there's a 50-50 chance that I'm going to get heads or tails. Experimental probability is if I sit here and actually flip that coin, what am I actually getting? So what is the probability of getting heads when flipping a coin? So one side is heads, out of 2 sides, 1 out of 2 probability. But if I flip a coin 2,500 times and I get heads 1,359 and tails 1,141, what's the probability of getting heads? Well, it was that 1,359 out of 2,500. Now, notice our theoretical probability is 1/2, which is equal to 0.5. But our experimental probability comes out to roughly 0.54. So those are not quite the same. They're close, but just because something's going to happen in theory doesn't mean it's going to happen in real life. So for a math class, you're required to roll dice 36 times, and the results of the experiment are below. Find the theoretical probability and experimental probability for each roll. So when you think about a dice, we have 6 sides. There's, for a 1, okay, so to help me display this, I've decided to make this table. The top is my roll, and then on the sides, the T for theoretical, the E for experimental. So the chances of me rolling a 1 theoretically are 1 out of 6. On a 2, or on a die, only one side has a 2 out of the 6 sides. Only one side has a 3 out of 6. Only one side has a 4 out of 6. One side has a 5 out of 6, and one side has a 6 out of 6. So theoretically, all sides or all numbers can be rolled evenly. And the probability of rolling each number is even a 1/6, or this is the same. But experimentally, if I rolled the dice 36 times, I only rolled a 1 6 out of 36. I only rolled a 1 6 out of 36 times, which actually is that 1/6. I rolled a 2, so I'm looking up here for these numbers, 7 out of 6, or sorry, 36 times. I rolled a 3 4 out of 36 times. Which is 1/9. I rolled a 4 9 out of 36 times, which is 1 out of 4. And then a 5 8 out of 36 times, which is 2 out of 9. And then a 6 2 out of 36 times, which is 1 out of 18, or 1/18. So we have our theoreticals 1/6 every time, but our experimental, it depended on the dice roll. It wasn't always the same. So that is theoretical versus experimental.